about a couple of years ago I bought this Pioneer F90 tuner, and the F90 tuner, along with a couple of the other higher end tuners, and I know it doesn't look like a high end tuner, got an excellent reputation for extremely high sensitivity and good sound reproduction. This is one of the better tuners, and I must admit it does sound, when it's working correctly, sound a really good tuner. This is the second tuner I bought. I bought this for spares or repair because the chap who was selling it thought there was something wrong with it, but he couldn't really explain what was wrong with it. And if you look back at one of my previous videos, you'll see that we ascertained there was something wrong with the tuning system. When you tuned, it wouldn't lock on to the channel, so when you were doing a tuning sweep looking for a channel, it would just search through and it would never stop on the frequency. And I'll show you that now with 93.5, which is a strong carrier. It just tunes straight past it and it never ever stops. The only way you can stop it is to put it in manual tune and tune it. I checked a number of things, and actually the Pioneer's service manual is actually quite informative and tells you quite a few things of how the system works and basically what's going on when you're tuning and things like that. And what it boiled down to, what I thought was anyway, it was this IF amplifier and sort of like tuning chip thing here, this P3007. Now this P3007 was unobtainable. I searched a couple of places. There was one chap in the States who wouldn't, just point blank refused to send it to me. You know, you wouldn't think a chip like that would be that hard to send in the post in a jiffy bag, and he wanted like sort of like 12 or 15 quid for a second-hand chip. So I basically gave up after about 6 months of searching and thought, well, it's obviously a tune that's going to be used for spares or repair. And it was about 3 months ago, I thought I'll have another look for a P3007. I did another search on eBay, and the same seller still trying to sell his second-hand chip, and obviously had no luck. I'm not surprising, because he probably only sell to people in his sort of local vicinity. So I started to do a search on Google, and I came up with a couple of the sites, and I don't know if anyone's had experience with this sort of thing. You type in part number in Google, and all these sites in China say, oh yeah, we got one of those, yeah, we got one of those, yeah, we got one of those. And a good way to catch them out is to make up a totally fictitious part number and type it in, and they'll say they got one of those. So you know it's all bullshit. But I typed in this number anyway, P3007. It's P3007, isn't it? Yeah, P3007, PA3007. Yeah. And came up with a normal sort of sites that come up with, say, yeah, we got this, we got that, yeah, there's no problem at all. Okay, and I found one of the sites that said they've got 30 in stock, and I'm thinking, well, okay, they've got 30 in stock, I wonder if they really have got 30 in stock. And they wanted, I think it was £12, something like that, for one item. And I'm thinking, well, let's take the chance. Okay, so I signed up into their account and typed in all my information they wanted, passwords and emails and things, which I used for a different. I've got this like a generic email account, so if I'm going to get spammed to death, I use my Yahoo email account. I'm not worried about that. And I entered the contact details and things like that, and typed in and paid £12, something like that, for PayPal, and that was it. And weeks passed, and I suddenly thought, oh, I wonder what ever happened to that chip. I haven't seen anything yet, I'm not expecting anything. So I logged back into their site once I remembered my email password for my email account and things like that. Logged in, and they said, oh, it's been dispatched, it's on its way. And I was thinking, oh yeah, okay. Anyway, I sort of that's fine, left it for a while, and sure enough, about 2.5-3 weeks later, I suppose total of about 3 weeks, the chip turned up. And this is the chip that's turned up. Now, it could be a total hoax, it could be a Chinese copy, who knows. It certainly looks very similar. It's got I don't know if you can see that the chips are sort of like got heat sinks extended on the end pins. It's not easy to see, I know, but It's sort of like extended heat sinking on the end of the chips, and that looks very similar to the chip I've got inside. So I suppose that really the case now is to what are we going to do? Are we going to take the chance? We're going to install the chip, or are we going to just let this tuner sit in the bottom of the cupboard and just basically scrap it? Well, I think we're going to install the chip. I bought a chip extender, so I can just hopefully desolder the chip that's in there. I can mount the new one in a header, and if that one doesn't work, I can at least put the other one back in and get some functionality out of the tuner. So I think it's basically the time to try it. This will be an interesting test because we know that a lot of these Chinese crap is basically got nothing inside it. This could be just a plastic chip with some metal legs on the side. We don't know, but someone's gone to a lot of trouble to make a chip that is extremely there's a very small market for it. You know, basically there's only a few tuners in the sort of like 80s that use this. Why would the Chinese go to such extent to copy a chip that is so rare and is so unlikely for anyone to ever want to buy one? Okay, so well, I think what I'll do is I'll start by taking this tuner apart, unsolder the chip, and let's get the header in. Okay, that's a picture of the underside. That's easy enough. Just to remove all the back screws and the screws on the seat PCB. And this is the chip we want to desolder. So the idea is, well, I normally do, if I know the chip's definitely knackered, I just cut the pins off it and just pull the pins out one by one. But what I'm going to try and do is desolder this with some desoldering braid and replace it with the header. So at least just allow us to put this other chip back if this chip has actually got nothing in it at all. So let's do that. Interestingly enough, there's a bit of sort of like darkness around this area here, and that just looks like where the transformer and the power supply is, but no sign of any burning or anything. It's in pretty nice nick. So nothing obviously wrong with this tuner. So let's make a start and get this, try and get this chip out. Well, that came out incredibly easy. Usually these are really hard to unsolder. I think it's probably a single layer board. I'll have to check in a minute. But this came out really easily. So that's the existing chip. So this isn't a futile attempt. But let's put the IC holder back in, and we'll put the new chip in and see what happens. Okay, let's re-soldered that back in. Pretty reasonable soldering, I think. Just that maybe that one leg needs a bit of a touch up. So let's give that a bit of a resolder. That looks like a sort of like a thermal plane more than anything. It's not actually, it doesn't look actually like a proper connection. Maybe it's a grounding shield connection or something like that. Let's reflow that. Okay. Happy with that? Okay. Let's put the board back into place, put the chip in and see if we get any better response from it. Well, from what I can tell, there doesn't seem to be anything wrong with this. So I started to perform an IF and front end alignment on this, and this is the IF alignment instructions here. Basically, first you set up the VCO for the top and low end range. That's test point 19 to 24.5, and then test point 19 to 18 at the other end of the frequency range. And then it's adjusting the front end oscillator, the coils, the matching coils, L1, 2, 3, T2, to get maximum signal. That's a conventional way of setting up a front end. And then TC1, 2, 3 at the high frequency to do the top end, same as any heterodyne. Then we moved on to the next stage, and that was to obtain a DC voltage reading at test point 16. What was that? Let's just move the... Yeah, obtain a maximum voltage reading across test point 16. That worked correctly. The next stage was to put a 60 dB, it says, at 98 megahertz, and then adjust T103 for 0 at test point 17 and 18. They are test point 17 and 18 down here. Where are we on these two clips here? and I can't get 0 volts on that. Now this is the coil we need to adjust, is this one behind this winding here, which is presently sitting at 400 millivolts, and I can't get that down any lower than that. I've adjusted that coil fully in, that gets you as low as possible, and then the top of the bloody core broke out, so the core's now wedged at the bottom of the transformer, which might require me taking it out. But that suggests there's something wrong, and it looks to me, though it says it's the discrete circuit, I don't think it actually says it's the discrete circuit there, whatever the hell that means. I think it actually means, if you scroll down to T103 in the manual, sorry this is all handheld, but there's no other way of me doing this. So scroll down here, where are we? Somewhere here? Here we go. So T103, you can see there, is marked as the discrete, FM discrete, and I think that's FM discriminator. And that sort of would ring true with what we're trying to do here. We've got to set the thing on tune and try and adjust the 0. So I'm just going to reset up the front end again, just check I'm doing everything right. So I'm going to put down 98 megahertz in. That's interesting, it's defaulted from the last thing I had into it. Doesn't usually do that. Strange. Anyway, and put the power RF on. Now we're just going to couple into the back of the tuner here with plug in. This is the tuner connections. I'm just going to go to the this should be fairly well matched. There's supposed to be a 50 ohm, 75 ohm input. This is a 50 ohm, but it'll be certainly, it's fine for doing IF stuff. That's not going to be a problem. You can get the clip to stay on, of course. So I need to tune in 98 megahertz. Let me just check it is 98 megahertz. Let's get this set up and I'll show you what I'm doing. Okay, so the Marconi is putting in 98 megs at minus 76 dB. I don't know where it gets its 40 dB. I don't know what they're using as a reference point, but 40 dB is 40 dBm would be something like 100 watts or something. So basically, I'm putting in a low-level signal, and that's what I imagine is our discriminator output. And you'll see that that's too high. And if I tune the radio, automatically tune, it will never stop at 98 megahertz, and it should do. It doesn't matter how powerful I make the signal. Let me increase the signal so you can see that. So let's increase the output power a bit. You can see the. Okay, got the tune light come on now. Okay, I'm putting quite a bit of signal into there, so you'd expect that to stop when you were tuning, wouldn't you? This is manual tuning, and automatic. If I press this button, it should tune, and it should stop at 98 meg. Go straight past it. Okay, so it looks to me like what it's doing is it's looking for the null. When you tune through a frequency, when you come into the tuning range, there'll be a dip in the discriminator output, or the product detector, or whatever it is, and that's what this chip, I imagine, this P3 007 detects and stops the tune. So what I think is happening is, because the discriminator is not nulled, it's not seeing that threshold, so it's just tuning straight past. It thinks that the station hasn't tuned in. Now the problem is with this, there is the winding is at the bottom of its core, and we're still not getting enough adjustment. So I think the only way I'm going to be able to do something with this is to, well, I mean, there's one jerry rig I can do, and I'll show you that. Let me just get it called up on the screen, and I'll show you what I'm planning on doing. Right, here's our. Looks like our discriminator output on this PA3007, and it says here that when it's tuned, it should be at 0 volts, and I can't get it at 0 volts. As you can see on the screen, I got it down to about 0.3. It was sitting around about 6 volts. This is all tied in with what looks like this coil here, which is the thing that says it's the discrete. And I think that's what that is, as you say, the discriminator. Now you can see basically it's a tank circuit, and there's a switch there for obviously turning the tuning system off. I think that bypasses the tuning or makes it jump to the next tuning stage. I'm not sure exactly what that transistor is doing, but it all works, that circuit. This is the core I've adjusted, as I say, and I'm looking for a 0 voltage on those 2 test points that I showed you on the board. Now, The only other thing I can do, I think we need more capacitance here. Maybe this capacitor's gone high, but certainly whatever I do, I put the cores wind round in, and I can't get this down. It was starting to drop, the voltage was dropping away, but it's still not enough to make the thing tune properly. So if I look here, these wires, you've got this capacitor here, which I want to increase the capacitance across. This R5600, this R125. But if you look, it goes straight across conveniently pin 1 and 2 of that chip. So what I'm going to do is I'm going to put a very small capacitor across the pins 1 and 2. See what that does to our voltage, and see if it allows it to tune better. And then if that works, I've got the choice of either trying to get this transformer apart, getting that core out and replace with a good one, or the other option to do is put a small padding capacitor across this point here and just tune it for null. That should work. I don't really want to take those transformers apart, because I break something in that transformer, the whole thing's scrap. So let's have a look. Let's put a small capacitor across pins 1 and 2 of this IC and see if that helps. I don't know if you can see there, I put a 2 nanofarad capacitor across pins 1 and 2, which is basically putting it straight across that tank circuit to slow the oscillator down. And you see now our output is actually dropped right back, and that's sort of in the ballpark figure we want. We want 0 volts, and that's 2 millivolts. So that looks good. I suppose the proof of the pudding will be, will it tune properly now? So if I tune up, I might put it on auto tune up, and tune back down again, will it stop at 98? Ah, well, it stops at 98.7, which is almost radio 1, slightly off tune, and that's probably because I've trimmed, but it looks like it's going to stop. It's stopping at stations now. So that's what it is. The discriminator output, because it's constantly high, it's never tuning in. So the next thing I need to try and do is I need to connect all this back up. So we'll connect this back up to 98 megahertz. Let's just have a look see what it's like at 98 megs on the dot. I need to stop that manually because I'm only putting a very low signal in. You've got a very low signal going in, so we increase the level a bit so we can get some drive into it. Make sure I'm in the right place. Just turning up the RF of the generators. We've got the tune light come on. Okay. So we have got a much reduced DC voltage on that discriminator output. So we're probably in the ballpark figure of where we want to be. Now it's a pity I can't turn that bloody core that's broken off in there. Because if I could, I might be able to bring it in now. But I was using the right tool as well, and it's just broken the head off the. What I could do, I have got some spare cores for these transformers, I think somewhere. What I could do is, if I need to add inductors, I might be able to put another core in at the top and get get this voltage down. So basically, what this is a frequency to changing the frequency alters the DC. So when it's at the correct frequency, when the discriminator's nulled, there should be no output, and that will be at 10.7 megahertz. When the IF set up. It's a slightly different way of doing it on these radios. You don't actually inject an IF signal, you actually tune the front end and then go through and sort of align the FM, but you don't actually directly inject the 10.7. So let's try and see if we can get this voltage down a bit. Well, that's a 2 nanofarad capacitor strapped across pins 1 and 2. That seems to be working quite well. I selected the lowest value capacitor I could find, and my offset's drifting around sort of 10 microvolts, 100 microvolts. So that seems to have fixed that, and now it's actually seems to be tuning reasonably well. It doesn't always stop on the center frequency. So what I'm going to do, now I've adjusted that, see it's slightly off. But it seems to be working far better than it was. These have got a really, really classy sound to them, these tuners. They do look, I know they do look a bit bland and a bit cheap, but it sounds really good. So I'm going to run through the full alignment again, and I think we can basically say this is finished and we can box the thing up. Okay, the final fix. It doesn't seem to be that critical what value capacitor you put on it. you can't actually get it down to 0 volts. And I've tried sliding a core into here, and you can never actually get it totally to 0. I don't know if there's something still wrong with that winding or not, but it is actually working quite well now, and it sounds great. It does, when you tune it automatically, it stops at the next channel, which is good, as you've seen in mode. So it's clearly working fine. So yeah, the tuner that's been sitting under the bench for what, 2-3 years now, I think can be put back together, and I think I really need to sell one of these tuners. I need to sell a lot of stuff, but this is a fairly valuable tuner. Maybe I'll pop it on eBay, and I've got the box and everything for it. It's complete, really, manual. So yeah, this is the Pioneer F90. Thanks for watching.